回家的人心事洒落在街上，忙到晚，不如出去走一趟。大好时光等你起床，我透过夜的黑，做的梦醉沉，唱着火辣辣的情歌，对你爱到底。我穿过夜的街，只为闪亮亮的心，遇见最好的自己，然后狠狠拥抱你。黑的夜，城市被孤单照亮，不回家的人心事洒落在街上，忙到晚，不如出去走一趟。大好时光等你起床，我走过夜的黑，做的梦醉沉，唱着火辣辣的情歌，对你爱到底。我穿过
Pure PLC automatic machine controlled by CMSCAPP. On the screen is a 3D model of an automatic machine. Let's see the machine. This is a bar of a mold. The aluminum rod dropped from here to the first position, and in the inner fixture coming from the material supplier down here and to the left, and with a piston push both sides, thrust inside the mold bar, and according to the moving mechanism, shift the bar to the middle with two machines coming pressed into the positions, and the 3 teeth moving press 3 holes in every 120 degrees. Thereafter, the bar and the inner piece will fix together, and after the 3 teeth drilling 3 holes, and then retract back and move back to its original position. Then, by the moving mechanism, the bar will go to the last position, and the outer piece supplier jump in positions in both sides. After holding by this facility, the insert rod from left and right together push the dark outer fixture and thrust in this position, and then retract back, and then continue a cycle. The whole driven by air pistons systems. No motion control cars axis movements. Is the particular demo of this example. The sequence control take too many times. For this PLC systems, we have 9 sensors for stations, 9 stations. Suppose in here, the sensor says there is materials. Then a script is executed and doing the binding procedures from both sides, thrust in and binding, and retract back to its original position. The 9 stations touch the sensor, sense the sensor, and touch the script procedure. Thereafter, the whole procedure times is very short and acceptable. In Industry 4.0, we can do the visual script. Running the virtual machines first to see the cycle time, to see the whole procedures before doing any fabrication of the physical machine. And after the physical machines established, and the wire, electric wire connected, the air pipe, whatever's installed, we're just doing some I/O point checking to see the function works, and then immediately we can run the scripts. If there is any distance, we have to adjust. Suppose for the outer fixtures fixed on both sides of the aluminum bar, here is a holder, the top holder and the button holder. The move distance for the button holders and the move distance of the top holders can be adjustable to the right positions to hold the bar in the right height as 2 pistons push the outer feeder in the both sides of the bar. Sort of adjustable suit for every piston. For every cylinder, they have both ends, the top end and the bottom end, all can be adjusted. Let's see the I/O table. This is the I/O table. The Y is output. Suppose Y1 is pushing the material piston. The Y totally in this system used 25 output points, while the input points S1 until S40, totally 40 inputs. The total points is 65, not including the sensor. The stage sensor, there are S1 till S9. 9 step sensors, and not including the emergency stop, the system's original fitted controlling sensor. Briefly speaking, the bar, alumni bar, dropped from the slope to S5. As S5 sense there is material, the Y6, Y9 will push the inner piece inside the bar tube from both sides. As Y6, Y9 retract back, the inner piece will drop because Y5 retract. First Y6 will in to reject the inner piece drop too much. The Y6 in resist break the supply loop, and the Y5 retract back. Then inside only one between Y4 and the Y5. Since Y5 retract back, this one will drop in position. Prepare for next pushed by Y6 in the alumni tube. In here, the same. As Y9 retract back, the procedure of Y7 will thrust in to separate one between Y7 and the Y8, and to resist the rest not drop from the material supplier. And the Y8 retract back, one piece of inner fixture will drop in positions, waiting for next assembly of the inner piece. In these kind of facilities, there are 1, 2, 3, 4, 5 pieces. Always to break the inner piece and retract open gate to drop one in position. This is the mechanism design. So 1, 2, 3, 4, 5, totally 5. The main supplier the same. The slope falling, use the gravity to before the bar. So we have to use Y2 thrust in to prevent the rest falling down the slope. So only one between Y2 and the Y3. As retract Y3 back, this one will drop in positions to touch S5. As S5 be touched the sensor, the script will running. The Y6, Y9 will push the inner fixture from both sides into the aluminium body from both sides. And the moving mechanism controlled by Y25. Y25, one I/O will let the cylinder move up to lift 10 aluminium bar from both sides fixed teeth, and then the horizontal pistol pushed by Y24 to push the whole system to the S positive direction, 50 millimeters distance. So every bar move one space. As S6 sense there is materials in position, the Y11 and the Y13 will be actuated by the script and push the whole mechanism up. Actually push the mechanism to the Y positive direction. This one to push the whole mechanism to the minus Y direction. As to the end, S16 touched, the movement will stop in position, and then Y10 will on. 3 teeth in distance 120 degrees will move toward the center to buy 3 holes at both sides of the bar, aluminium bar. This binding will let the bar and the inner teeth fixture fixed in positions and never move anymore. After binding, the Y10 will off. The 3 teeth will retract back to its original position. As X13 touched, the procedure finished, and then Y11 retract the whole mechanism, move back to the Y positive direction. As touch X15, the whole mechanism back to its original positions. the cycle movements finished. As the cycle finished, then the moving mechanism actuated, just like what we already said. The Y25 will leave the moving mechanism to let the 10 bars leaving the fixture supporter at both sides. Then Y24 actuated to push the whole mechanism, including the 10 bars, to the x positive direction, 50 millimeters, to shift one distance. As the S32 sensor on, the whole mechanism to the right and the position, and the Y25 off, the mechanism will lower down. The 10 bar will in position and leave the inner moving mechanism, and then Y24 retract the mechanism of the moving, will retract back to its original position and finish a moving cycle. Then the S7 sense there is materials. The button holder Y15 will on to go a distance upper. The Y16 will on to push the holder down a distance to form a channel to hold the toolbar in the exactly Z position, to let Y14 and the Y19 to push the outer fixtures to fixed on both sides of the aluminium bar. As Y14 and the Y19 retract, the S8 will work. First, Y18 actuated to thrust in to prevent the out fixture drop from the material supplier, and then retract Y17. So only one between Y17 and the Y18 outer fixtures will drop in positions, waiting for next thrust in. Thrust in for what? For fixed on both sides of the aluminium bar. This is the way the system does. Every movement by control, by cylinder, air cylinder, and by PLC output and input sensor. The whole procedure from S1 to S9 is not in sequence. If in sequence, it will take long times to finish one cycle. Whenever there is a sense S7 has materials, the script of S7 will automatically actuate it to hold, to push, and retract. The S6 the same as well. Whenever S6 sense a material in here, the Y11, Y13 will push the binding mechanism from both sides to the center and touch the end center sensor S16 and the S20. The Y10 and the Y12 will actuate it to bite the both sides of the aluminum bar to fix the bar and the inner fixture, inner teeth fixture. So the 9 script actually actuated in suitable time. Actually, maybe some at the same time, depends. Definitely not the S1 to S9 in sequence. So the cycle time take about 5 seconds to produce one product. So 1 minute can produce 12 pieces to suit the requirement of the customer. The 9 sequence S1 to S6 is similar to X input sensor, but this is S is for sequence use. Okay, let's see the virtual machine operated by CMSCAPP. The script already feeding S1, P1, the material sense program, S5 in, the P5 inner teeth assembly script will be actuated. S6 from 0 to 1, the script of P6 press and moving script program will be actuated. And running and rounding until on purpose stop. Okay, let's see the simulation. In PLC mode, as we open the machine, you will see the machine is running. Let's to see in more detail. You can see the holder. Moving up to prepare a hole and press in the outer fixtures and retrieve back according to the script. And you can see here from the supplier of the material drop down the first display in, so plenty materials at the top. As we need one display thrust in to prevent the drop at the top, and retract the display off to let the single one drop in positions. Prepare for the piston to push it to assemble in the center. And you can see the moving mechanism. The vertical piston will leave the inner teeth up first, and the horizontal to push the whole facilities to the X positive directions. The 10 aluminum bar will shift one space and lower down. So the 10 aluminum bar will support by the outer fixed teeth, and retract back its original positions. So the moving mechanism running a cycle to shift the 10 aluminum bar 10 togethers to the X positive every time 50 millimeters to the next teeth. You maybe wonder why there isn't any parts on the simulation. This is what we want to say. Want to explain. Don't you see the machine working slowly? It takes one cycle almost 2 minutes. If we still putting the parts, it will take more times to finish one cycle. It's not acceptable for the physical machines. This is only for simulation, for script writing, to see every movement in position or not, and to see the whole scripts works correctly or not. For actual machines, we have to release something to take more models out, the better, for better looking, for faster movements. Actually, the fixed parts of the machines and the controller is no use. If we remove the fixed materials and run the machines, then we can get the physical cycle time. Okay, let's show. We reset let the operation cease, and use new to remove the 3D models and the scene input name of scene to adopt a scene without the fixed parts. You can see right now on the screen is only the moving parts which is actuated by air cylinders or whatever, and the input script still the same. And let's run in the machine to show you the really control of pure PLC automated machine working. So we press PLC modes first. We use the first PLC, the PLC 1 mode. As we push the cycle starts, the system is running. You can see nothing but the moving mechanism very clearly to see every action. You can see the binding machines thrust in, and the teeth, the 3 teeth in distance 120 degrees binding the aluminum bar to fix the aluminum and the inner teeth fixture. And after binding, they will retract back to its original position, and the whole binding system will retract back to its original position as well. And you can see the moving mechanism. The first leaf, the second horizontal shift to X positive distance 50 millimeters, and drop down and retract back. Fourth throw, 4 movements to finish 1 cycle of the moving mechanism, driven by 1 vertical cylinder, another is horizontal cylinder. And you can see the vertical sliding, this sliding bar. The lifter slide on top of the sliding bar. For every moving distance, we can adjust the visual script. Suppose in here, on purpose, we want this one to go a little further to show you it's working. For the whole system with the outside the fixture parts, you cannot see the move of these pistons towards the Y positive distance, as it stopped in here, still behind by the structures. You cannot see the working of this piece. That's the reason why in the demonstrations we on purpose to let this one move in the distance a little further to show you it is working. This cycle time 5 seconds to make 12 pieces per minute. So on the virtual machines, we still can use this way to count the cycle time for the future physical machine. If the cycle time acceptable, then we commence to fabricate the physical machines. This is what the Industry 4.0 visual script does. Why we say this is a visual script? Because you can see the script in front of your eye before the physical machine. If the machine's design supports by SolidWorks, the designed machine's geometry materials is used for the 3D simulation, as well as the fabrication the physical machines according to the SolidWorks designed materials. Then the virtual machines and the physical machines is all in one, is similar. And for these simulations, only for the moving parts, there is no delays because of to display the fixed machine body. The cycle time of the actually moving parts to predict the physical machine's cycle time. Okay, this is a publish of the real pure PLC driven automatic machines. Ending.
嘴唇唱着火辣辣的情歌，对你爱爱到底。我穿过夜夜夜的街，只为闪亮亮的心，遇见最好的自己，然后狠狠拥抱你。我走过夜夜夜的黑，做的梦梦梦嘴唇唱着火辣辣的情歌，对你爱爱到底。我穿过夜夜夜的街，只为闪亮亮的心，遇见最好的自己，然后狠狠拥抱你。走过夜夜夜的黑，做的梦梦梦嘴唇唱着火辣辣的情歌，对你爱爱到底。我穿过夜夜夜的街，只为闪亮亮的心，遇见最